What was the pattern, McCarvin? Yeah. It was +4, okay? So let's write that in there. We're adding 4 each time. So if we're adding 4 each time, okay, what would the next 4 numbers be? Alfonso?
37, 42, 48.
Yeah.
48.
Wait, did you say 48? No, it's not 46 either. 45, bruh. Are we good? Questions on that? Okay, this is what we're doing today, is we are finding patterns in something called a sequence, okay? A sequence is just a list of numbers like we had, right? But we're going to be able to predict what the next few numbers would be, okay? All right, put your iPads face down really quick. So, those sequences were just a list of numbers, right? Now, a specific form of sequence is called an arithmetic sequence. Underline it, okay? Arithmetic sequences are sequences where you are only adding, or what's the other thing other than adding? Subtracting. AJ, what's up?
Do we add this to the warm-up page?
It is the warm-up.
It is the warm-up.
I didn't know that. I took a picture of it.
It's the 4.6 notes.
Oh, I didn't even.
Okay? So you can only add or subtract. If we multiply, will it be arithmetic?
No.
If we divide, will it be arithmetic? If we add, will it be arithmetic? Yes. Okay? Adding or subtracting means it's arithmetic, okay? Now, let's define some things first and foremost. A sequence, just like we saw in the warm-up, is just a list of what? Numbers, okay? Now, in that list of numbers, each of the numbers is called a term, okay? Okay, so in each of those sequences, there's a list of terms, okay? Take a look at the first sequence that we're given, okay? Is this sequence... All right, so each of these sequences is going to have a number of terms. How many terms does this sequence have, guys? 5, okay? So there's 5 terms here. Now, each of these numbers is in a position, okay? And we start labeling the positions by 1, 2, 3, 4, and 5, right? So which number is in the first position?
5.
The 5. Which number is in the 5th position? 25, okay? So we're going to label them. Position number 1 is number 5. Position number 2 is number 10. Position number 3 is number 15. And position number 4 is number 20, okay? That position is going to be labeled by the number n. Okay? So if it says the nth term, or for example, the 5th term, which of these has a position of 5? 25, okay? So that's how you locate which term it's talking about in the sequence. Now, you're also going to see a different kind of notation that we haven't seen before, and it's called A sub n. And this just references whatever term it is at that position in the sequence. So, for example, which of these would be A in the first position?
5.
It's 5, okay? So A sub 1 is up here. Which of these would be A in the third position? 15, okay? So on and so forth. Let's just do ones to make sure that we got it. What would be A sub 4? 20, because 20 is in the 4th position. Does that make sense? So the little number on next to the A that's really small, that's telling you, okay, which position do you need to access, okay? Questions on this so far? Does this make sense?
Yes.
Okay, it's the first time we're seeing it, so the notation's a little bit weird, wonky, but it'll make sense once we start to do some practice with it, okay? Now, in arithmetic sequences, the difference between each pair of consecutive terms must be the same. You can't add by 3 and then add by 7 and then add by 9. If you add by 3, you have to add by 3 the entire time. Otherwise, it's not arithmetic, okay? Now, whenever we add by 3, for example, that's what we call a common difference, okay? So look at the sequence that they gave us in the beginning. It was 5, 10, 15, 20. What are we adding each time to those numbers, Christian? We're adding 5. So our common difference is plus 5. Notice, Did we add the same thing each time? Yes. You cannot add different values each time, okay? So if they add 2, then 3, then 4, then 5, there's a pattern there. Do you guys agree? But it's not arithmetic because it's not adding the same thing each time. Yes?
So what if it was like add 3, add 4, add 3, add 4?
Add 3, add 4, add 3, add 4. Do you guys hear that? Is there a pattern there? Yeah, they're alternating between 3 and 4. Is it arithmetic? No. So in order to be arithmetic, what you are adding or subtracting by must be the same. Good question. Any other questions on this? What if we had, this one's going to throw you guys off, if we had 2, 4, 8, 16, so on and so forth. Let's first notice the pattern. What's the pattern? Nick?
Times 2.
You're multiplying by 2. Do you guys agree? Now it's the same each time, so isn't it arithmetic? No, why not?
It's not adding or subtracting.
You can multiply, it must be addition or subtraction. So write that this guy's not arithmetic. Do you guys think you get it by now? Does it make sense? Be honest. Are there any questions?
No.
You guys ready for the first few examples? Let's do this thing. Okay, so we're going to write the next 3 terms of each of these sequences, okay? So first, identify the pattern, and then we'll start to write the next terms. What's the pattern here? AJ? They're subtracting 7 each time. So what would the next 3 terms be? Someone else. What would the next 3 terms be? Christian? Very good. Negative 35, negative 42, and negative 49. Is it arithmetic?
Yes.
How do you know?
Because it's the same.
What's the same?
The common difference.
The common difference is the same. Do you guys see that? So if you're subtracting the same thing each time, it's got to be arithmetic. And what is the common difference here? Negative 7. Did you guys hear that? So if it's going down, what sign is your common difference going to be? Negative. If it's going up, what sign is your common difference going to be? Positive. Okay? Check it out. We're going to do C first. Okay? We're going to do C, and then I'm going to let you do B and D on your own. Okay? In C, what's going on here? McCarvin?
They're adding 0.4.
Good. Adding 0.4, adding 0.4, adding 0.4. Okay? What is the 0.4 then? What do we call it? It's the common difference. Very good. What would the next 3 terms be? AJ?
1.8, 2.2, 2.6.
How do we feel on this? Confident? Okay, try try B and D to make sure that we get it. Go. Example B.
Add 12.
Oh my gosh, AJ. Don't call out. Who knows it and can raise their hand politely? Miss Gagne. Very good. We're adding 12 each time. So, Miss Gagne, what would the next 3 terms be?
36, 48.
How many of us got that one right? Raise your hands. Hey, let's go. Okay, moving on. The next one. This one's a little bit dicey. Miss Addison? Very good. You're subtracting a 4th each time. Now, for those of you that did not see that naturally, check this out. This 1/2 is the only one without the same denominator. Did you guys agree? Change the 1/2 to have the same denominator. What is that fraction? Addison? 2/4. Now you're going to see, oh my gosh, aren't they going down by 1/4?
Oh.
Cool, right? So what would the next 3 terms be? Austin?
3 and 2, 2 and a 3 over 4, and then 2 and 1/2.
Very good. And then 2 and 1/2. Okay? If you put 2 and 2/4, are you also correct? Yeah. But will you lose points? Why? You must simplify. Are we Gucci there? If you put 2 and 2/4 here, you are going to have to simplify to 2 and 1/2. Oh.
I don't get it, Frank.
What?
I don't get this.
You don't get this? Okay, David. Well, when you look like that, it doesn't seem like a term's position number n in the sequence be the x value. So if its position is 1, its x value is going to be 1. If it's in the second position, its x value will be 2. The term a sub n is the corresponding y value. So if the term's number is 5 at 1, its position is going to be 1 and its value is going to be 5. So 1 comma 5. Then you plot the ordered pairs n comma a sub n. So its position and then its value at that position. Okay? So let's do the first couple. How many numbers do we have in this first sequence? There's 4. So how many positions do we have? And they're going to be labeled 1, 2, 3, and 4 every single time. Okay? If it gave us 5 terms, how many positions would I have? 5, and they would be 1, 2, 3, 4, 5. Do you guys get that? Okay. Which term is in the first position? Addison. It's 4, okay? Which term is in the second position? 8. The third position? And the fourth position. So now, each of our coordinates is going to be the position and then the term. So my first coordinate is what?
1, 4.
1, 4. My second? 2, 8. Third?
3, 12.
And the last?
4, 16.
Plot them. Minus 4, 16, because that one is going to be off the graph. Plot the first 3. Plot the first 3. The fourth one's going to be off the graph, so you can add it up to 16 if you want and like put a dot like all the way up here if that floats your boat, okay? But you don't have to. Just plot the first 3. What do you notice about these 3 points? Let's make some observations here. David?
They're in a straight line.
Yes. They lie on a straight line. What else do we notice about these points? McCarvin? They have the same slope. What is the slope?
+4.
It's 4. They have the same slope of 4. Miss Gagne? It is a function. Very good. Why is it a function?
Because none of the x values are the same.
None of the x values overlap. Very good. Yeah. It's positive. What's positive about it? We call that a positive correlation. Very good, Mr. Salucci. What else? Yeah.
It's parallel
Parallel to what?
to, we're gonna do,
Okay. So parallel, to determine if 2 things are parallel, you need 2 things, right? We only have 1 here. What else, Karen?
It's linear.
It's definitely linear. Very good. Because it's going to lie in a straight line. Perfect. Write this down because this is the most important thing and the thing that people mess up on all the time. You do not draw a line here. Because this was a sequence. Okay? When we write equations, y equals mx plus b, right? You guys have heard me say that a million times. Do you guys agree? We always draw a line through them. Do you guys agree? Here, this is a sequence. We have individual terms, right? Is one of our terms 6? Is one of my terms that I was given 6? So if I drew a line, though, do you agree that my y value would eventually be equal to 6?
yes.
This is why we don't draw a line. Because these sequences are individual numbers, right? So we're going to have individual points. If we fill in that line, we're saying, okay, all of these other points that lie on this line should also be parts of our sequence. But they're not, okay? So we're not going to draw the line. Did we write down that star?
Yes.
Okay. So all we're going to look at is that. I'm going to ask one more question. What was the common difference of this sequence?
+3.
What was the common difference of this sequence? AJ?
Add 4.
You're adding 4 each time. And that number will always be the same as what? Your slope. That is the connection I would like you guys to make. Okay? Whatever your common difference is, it will always match whatever your slope is on the graph. Now, I may not ask you to apply that, but it's a great tool for you guys to check when you're done with the problem. To be like, okay, I should get this right if my slope and my common difference match up. Otherwise, I didn't do it right. Are there any questions on this one? Sweet. Let's move on to the next one. We'll do one more together and then I'm going to set you guys loose. Okay? How many terms am I given?
4.
So how many positions do I have? 4. 1, 2, 3, 4. What's in the first position?
3.
Second? Third? And fourth? What are my 4 points?
1, 3.
Second point.
2, 6.
Third point.
3, 9.
And last one.
4, 12. I did that by
Let's
myself.
plot them. And then I'm going to draw the line through them. Colin? Thank you. Guys, do not draw that line. It almost happens naturally, right? Because we've been graphing so much. Why don't we graph this one? Why don't we draw the line through it? Natalie?
Because well, you're not supposed to because you're only supposed to use the term that they give you.
Very good. It's what are we graphing? Are we graphing a line or are we graphing a sequence? A sequence, okay? These are individual terms. Got it?
Yeah.
Okay, try C and D on your own.
Oh my god.
See? Did you guys hear that?
Rookie mistake.
Mia accidentally drew a line through it. It happens, okay? But Mia, what are you going to learn from this?
Not to draw a line.
Not to draw the line. You? 30 seconds, go. Talk about it. 1, that's that point. How do you plot 0.8? 2 comma 0.8. How do you plot that?
Between the 0 and the 1.
It's between 0 and 1.
It's close to the 1.
It's closer to the 1. Why?
It's close to 1.
It's closer to 1 than it is to 0. Do you guys agree? And then 0.6 is closer to the middle. And then 0.4 is just slightly below the middle, right? So make sure you're efficient at plotting decimals because this matters, okay? All right, last 2 examples and then we're donezo. Let's do it, okay? Does the graph represent an arithmetic sequence? Well, how do we know if something's arithmetic or not on a graph?
Difference.
There should be a common difference. Very good. AJ?
Slope is the same.
The slope should be the same. And what can we draw through all of the points? A straight line.
What?
Thought you said
Okay.
You said not to.
Exactly, but could we technically, right? So we're not going to, right? But could we draw a line through those points? Now, let's check it to make sure. Let's list our numbers in position order. What's my first number in the first position? 15. Then what?
12, 9.
Then 12. Guys, my first number is not 1. This is the position. This is the actual term. So what's my first position's number? 15. What's my second position's number?
12.
What's my third position's number?
9.
What's my fourth position's number? 6. So we have to list them in that order. Now, what is the common difference going from 15 all the way down to 6? What's the common difference between all these? Yeah. We're subtracting 3. Notice, were my points going up or were they going down?
down. Negative slope.
It has a negative slope. Very good. Or a negative
Correlation.
correlation. You guys notice that?
Oh, I thought negative correlation was when there's a scattered plot.
This is technically a scatter plot, right?
Oh, there's no line.
Correct.
Oh.
Okay? All right. What about the next one?
Okay.
Oh, wait. We didn't answer the question. Right? Does this graph represent an arithmetic sequence?
Yeah.
So this is an arithmetic sequence. Yes, it's an arithmetic sequence. Now why?
It has a common difference.
Very good. It has a common difference. What was the common difference here, Alfonso? It was negative 3. Okay? All right, let's look at B. Just eyeballing this, How could I kind of be like a little bit suspicious that this is not going to be an arithmetic sequence? Sophia?
If you draw a line, it's not straight.
Very good. All these points are not going to lie on the same line. Do you guys see that? It kind of looks like it would be like a curve almost, right? So how do we check for sure? List out your sequence in order. What's my first term? 2. What's my second term?
4,
My third term? And my fourth term?
11, 7, 11.
Let's go ahead and find the differences between each of these terms. How do I get from 2 to 4? Natalie? You add 2. Then from 4 to 7? From 7 to 11? Now, guys, don't be confused. Is there a pattern here? Absolutely. But is this arithmetic? No. Why not? Okay. There's no common difference. We're adding by different things each time. So there's no common difference. And why is there no common difference? Or what does no common difference tell us about this sequence?
It's not.
The slopes aren't the same.
Yeah, the slopes are not the same. But more specifically, what question were we trying to answer in the beginning?
It's not.
It's not.
It's not arithmetic. Now, I know some of you guys have seen that